You must have heard some people say we should ditch object-oriented programming in favor of procedural programming. Procedural is fine at a microscopic level, but trying to implement a business application in procedural style is outright impossible. I will now show you why we must augment procedural programming into something larger, more powerful, into object-oriented programming, if we want to implement even modest business requirements. Here's the demo application. I have prepared model classes to define books and some data source. It returns an array of book objects. I would like to implement some processing on books. What shall we do? Remember, we will stay within premises of the procedural programming at first. Shall we for each through the books? Sorry, there is no such thing as for each in procedural code. The for each loop requires polymorphic implementation of the iterator. That kind of polymorphism is off limits to procedural code. We must use the knowledge of a concrete collection to iterate through it. We must also use the knowledge of the data structure to extract target items. Only then do we step to doing the actual work we planned with the data. That is one annoyance we can already observe that relates to procedural programming. Now we call the procedure, it does the work, that's fine. The problem, however, comes with variation. A very frequent request is to vary the data structure. Here is the linked list, a specific data structure very different from the array. In this line we also see generics, that is another kind of polymorphism trivially implementable in any object-oriented language, but off limits to procedural languages. Some workarounds were used in procedural code to produce effects similar to generics, but that is so 1960s, you don't want to see any of it. The bigger trouble here is with varying collections, they are not interchangeable. No matter what we have made so far, we must make it again if we want to support two kinds of collections. Looping for the linked list is substantially different. We must follow the links to visit all nodes. There we meet our friends we thought were dead, null pointers. You can forget about nulls in almost any object-oriented piece of code you write today. But if you are writing procedural code, nulls will be jumping around every corner, you can bet on that. And then right in the middle of all this mess, you will plant your domain-oriented piece of code. We already see some serious drawbacks of procedural coding. The domain-oriented code, the only one we care about, is planted in the middle of a bunch of infrastructural code. This coding style is usually referred as spaghetti code, and varying the domain implementation, which is a frequent request, quickly becomes difficult. It is typical to try to vary behavior through function parameters. That will inevitably add to the complexity, and we will wish to move behavior out into a dependency. That is another trouble with procedural programming. If we did nothing, spaghetti code would lead to enormous code repetition. Now we want to move to pull the repeated code out, and that would be in form of function injection. Procedural programming knows about first-class functions. We would simply invoke the injected function, but with a caveat. The good thing is that the caller could inject any implementation of a function that meets the signature, and in that way extend the behavior of the procedure we are implementing. That is the good part. I will put an empty action here, but you get the point. This is the place where you extend the procedure without modifying it. And there is the caveat. The parameters of the extended behavior will still be the parameters of my procedure. In this example, I must pass the colors to the procedure, even though the procedure doesn't depend on the console and console colors. There it is. A giant problem in procedural programming is the lack of abstraction. We will have to deal with this very soon, but now there's a game for you. If you don't like this code you see here, then please press the like button, because now we're going to start fixing this. You see, this is as far as the procedural programming will take you. The code will be unreasonably complex for the work it is effectively doing. Infrastructural code will be mixed with domain-related code. There will be misplaced abstractions of all kinds, which we recognize in enormous and ever-growing parameter lists. One word: encapsulation. There is none here. And one more word: polymorphism. We need true encapsulation and polymorphism to be able to develop any business application. Business applications are built on top of dynamic rules, hundreds of them. You cannot model them using just procedural programming, no matter how hard you tried. This procedure is a good example. Keep adding the requirements and its argument list will explode. I will now show you the proper way of addressing these burning issues. First, I will move the procedural code into its own module so that we don't have to look at it anymore. And let me remind you that you can download the entire source code, including both the procedural and object-oriented implementation I will develop, from my Patreon page. Join the growing community of people who are sponsoring the content on my channel. That will give you access to all the source code from all the videos on this channel and the source code of this video too. Back to the caller, we can still call the procedures and control them with parameters. If that is the level of complexity you're solving, then it's alright. Procedural programming is perfectly fine at this level of complexity. But you have already seen the problem with parameters and the lack of abstraction. So the complexity is already greater than we can handle. The first real issue here is that with data encapsulation, we're missing encapsulation. These parameters, they belong to the procedure passed as the argument, not to the procedure we call. And there are two principal ways of removing superfluous, unwanted parameters. One is to use a closure, and that would push us in the direction of functional programming. That is a perfectly fine solution. The other is to use objects as a means of encapsulating data. What is the request here? It is to report books on the console. We had those colors to manage. The colors become the encapsulated state of the object this time. If you wish to use two sets of colors at runtime, then have two objects of this class. The object should be able to report books on the console, so here it is, the encapsulated private behavior. And guess what? It is 100% procedural. Procedural programming is perfectly valid in all places where all we need is a procedure. Just use it. But now comes the behavior that the consumer requests. The caller will want to report a regular book or to report a warning. You see, we can expose multiple pieces of behavior from a single object rather than passing multiple procedures to another procedure. Better yet, we can add new behavior without affecting the signature of any procedure or any other object that uses this object. There is an important note to make here. This class is encapsulating dependency on the console, including the color codes. It's private. No caller will ever know that a certain class, console in this small example, even exists. That is how object-oriented programming is reducing code complexity in an extremely efficient way. All we have to say at the consuming end, we say through an object. Parameters go here along with any transitive dependencies, and here comes the function which processes those books. There we see another great advantage of object-oriented programming over procedural, the abstraction. Abstraction based on polymorphism. We can abstract away any data structure so long as the concrete implementation gives us an abstract way of traversing the items in the data structure. Add syntactic sugar and there you have it. The for each loop, such a wonderful, simple concept that could never exist in a pure procedural code. Then, inside the loop, we are free to step back to good old procedural coding again. There's nothing wrong with procedural code, you see. But still, even though the calls I made here are resolved statically, we can augment them into polymorphic calls. This is the interface which would decouple a caller from a concrete implementation and even remove dependencies on any concrete classes that implement it. Decoupling is very welcome in any complex application we write. Then, why not use generic type polymorphism as well? Any concrete class would only be an implementation of the interface. You would expand a method, a function, by injecting a polymorphic object, any interface, maybe a generic one. You would define this behavior inside a class. If the method is stateless, you can make it static or even apply it as an extension method. And when you move the definition of that class away, you only remain with the parameter object and the subject to which this method applies. And there you will witness how object-oriented programming shines, especially compared to so much more limited procedural programming. A method would apply to all collections uniformly. There will be no code duplication to support different data structure, an important point to make. And more polymorphic behavior of collections, sequences, custom classes with the generous help of first-class functions, generics and all, will let you attain pieces of code beyond the wildest imagination of procedural programmers. Now, if anyone advised you after this to abandon object-oriented programming and only use procedural programming, then ask them to implement this demo in procedural style and you will see. Or just ignore them, that idea was stupid anyway. Join the sponsors of this channel, download the source code of this demo, read it, keep writing good code and see you in the next episode.